Hello and welcome. Today's lesson is all about answering the question, what is crude oil and why is it useful to us? My name is Mr. Watts, this is What's Your Question, let's kick things off. Objectives for you today then, we have three. The first one is to recall just what crude oil is in the first place and how we can make crude oil useful. You're next going to be able to talk about the structure of the parts of crude oil. These are the alkanes. We'll talk more about what we mean by that in a few minutes time. And finally we'll talk about how we can use a process called cracking to make those alkanes, those parts of crude oil, more useful to us. Crude oil is a fossil fuel we find underground, made of the remains of living things from millions of years ago. Over time, those animals died, those living things died, they lay on the ground as they passed away, and they were then covered up by rocks and other things. As they got covered up more and more, they sank into the ground more and more, until eventually they were so far underground, they were squashed by heat, squashed by the rocks above them, and heated by the heat beneath them, till they formed an oil. This happens over a long time. This crude oil is made up of carbon and hydrogen, and the substances formed inside of it are what we call alkanes or hydrocarbons. These substances are really useful to us. Once we've got this mixture of hydrocarbons out of the ground, this crude oil out of the ground, it is a mixture of lots of different molecules of hydrogen and carbon mixed together. Because it's all these different molecules, we need to separate them to make them useful, so they are each individual molecule that we can then use. To do this, we use what's called a fractionating column and a process called fractional distillation. This image shows us what that looks like, okay? You can see the arrow at the bottom shows you where, on the left-hand side of the image, shows you where crude oil is fed into the column. You can see at the bottom of the column, it'll be very hot, and the top of the column will be very cold. And this means as you rise up the column gets colder and colder and colder. Because it's so hot at the bottom of this fractionating column, when we feed the crude oil in, what happens to it is it immediately will turn to a gas if its boiling point is below that 350 degrees that we have at the bottom of the column. If its boiling point is above that temperature, this substance will remain a liquid and will drip out the bottom of our fractionating column, and you can see that bitumen in this diagram is coming out of the bottom because its boiling point would be too high. The rest of the substances would become a gas, and because they are hot, they would rise through the column. Now, as the column gets colder, those substances would get colder as well, and at each of their different boiling points, they would condense back into a liquid, drop onto the plates you would find there, and run out of the tubes that would be at the side of the fractionating column. And you can see that as we move up, we get different substances, things like fuel oil, diesel, kerosene, gasoline. Those substances that remain gas all the way through, even when it gets down to 25 degrees C, would come out of the top of the column, and that would be things like methane for us to use as our natural gas as well. These molecules are made up of different sized, these substances are different sized molecules. The longer molecules would end up coming out of the bottom of the container, and this is because longer molecules are bigger. Just like bigger planets have stronger gravity, bigger molecules have stronger forces between them, giving them higher boiling points. Those small molecules, we'll look at these in more detail in a second, come out of the top of the column because they are smaller, have less strong intermolecular forces, so are less attracted to each other, so their boiling points are lower. Crude oil is made up of hydrocarbons, okay? Hydrocarbons are substances that are made of only hydrogen and carbon. If they only have single bonds, like all the ones in crude oil do, we call them alkanes, and you can identify an alkane by its name. The name of alkanes always ends in A-N-E. The rest of the name, the first half, tells you how many carbons there'll be. Meth means 1, eth means 2 carbons, prop 3 carbons, bute 4 carbons, and pent 5, and so on. It continues after that in the same way that your shapes would be. So hex is 6, hept is 7, oct is 8. The structure of these is fairly simple. For every 1 carbon that there's 4 possible bonds it can make. So if we have 1 carbon, for example, it will contain 1 carbon and 4 hydrogens. If there's 2 carbons, one of those bonds connects the carbons and the other bonds are taken up by them bonding with hydrogens. If you don't know what these are molymods, and they're just really good for visualizing those structures, so you can understand how to help you understand what they look like. So these are really useful. They don't cost much if you need to think visualizing will help you. So that's methane and ethane. We also have propane, which has got 3 carbons in it, and each of those has got 4 bonds still, and all the bonds that aren't connecting the carbons are connected to hydrogens. And then we have got butane, which has 4 carbons, 4 of the black balls we can see here. We can also draw these structures out. We can see that for every 1 carbon, there's 4 hydrogens here, and again, those same structures are shown in this way, where we have 1 carbon, 4 hydrogens, 2 carbons as hydrogens as well. Now, you can predict how many hydrogens there'll be if you know the number of carbons. So if you know the name, you can work out how many carbons there are, you can then work out how many hydrogens there'll be. And you can do that using the formula CnH2n plus 2. And that means that for however many carbons there are, there'll be twice as many hydrogens plus 2. So 2 carbons, there is 6 hydrogens. 2 times 2 plus 2, 6. For 4 carbons, there is 2 times 2 plus 2, 10 hydrogens. And the same is true for all of these. In terms of the substances we extract from crude oil, some of these are more useful than others. And this graph shows us how much demand there is for each one and how much is being supplied of each of these. Now, if you look at LPG, you can see there is a higher demand than there is supply. So we're not getting as much of these as we require. We need more than we have. The same is true for petrol, for diesel as well. LPG is a smaller molecule, and as we move to the left-hand side of this graph, these molecules get bigger and bigger and bigger. And you can see clearly that the bigger molecules on the left, there is excess of these. There's too many of these. We don't need as many as we have. Usefully, we can take the extra that we don't need and we can make them into shorter molecules for us to use through a process called cracking. When chains of hydrocarbons are too long, they become less useful. So we need shorter chain hydrocarbons to make them more useful at the minute. So we can take those long chain hydrocarbons. This one, for example, has 10 carbons in it, and we can break this chain to make it shorter using cracking. This diagram shows you cracking, a setup for one method of cracking. We heat the substance, in this case they've used paraffin. We pass that over porcelain chips, which work as our catalyst, and that breaks the long chain hydrocarbon down to make it shorter. Now when that happens, the bonds in one part of the structure will break. Then one of the hydrogens on our shorter section fills the gap that makes on that chain, making this a bit shorter. And then we end up with that spare bond on this structure, making a double bond with our carbon there. This substance is no longer an alkane because it has a double bond. This substance is now an alkene. The rules of the names work the same with this, so this would start with prop as it has 3 carbons, but would end in ene because it's an alkene. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.